The diagram below shows a sketch of the triangle ABC with AB equals 5 centimeters, AC equals X centimeters, BC equals 11 centimeters, and cos BAC equals 2/5. Write down and simplify a quadratic equation satisfied by X. Hence, evaluate X. B. The triangle XYZ is such that XY is 32, XZ is 15, and XYZ angle is 19 degrees. Find the possible values of the angle YXZ. Give your answer correct to the nearest degree. So let's have a look at this then. We can use the cosine rule here for part A, can't we? So A, here I've got the question in summary form. So this squared, A squared, 11 squared, is equal to B squared plus C squared, 5 squared plus X squared, minus 2 times B times C, so that's 5 times X, cosine of the included angle, which is 2/5. So we can just put 2/5 down, can't we? 2 over 5. So what do we get here? So we get 121 is equal to 25 plus X squared. Here the 5's will cancel and we get minus 4X. So that tells us then that X squared minus 4X. 25 minus 121 is minus 96, isn't it? Okay, so that's all brought over this side now, and that equals 0. So what's the answer then? Here we've got 96, which is 6 times 16, which is also 12 times 8, 96. So we can factorize now. 12 and 8 have a difference of 4, so if we put 12 and 8 in, this should work, shouldn't it? So it's going to be minus 12 plus 8, isn't it, to give the minus 4. So X squared minus 12 plus 8X is minus 4X, and then we get 8 12s and 96, plus and a minus is a minus. So that tells us then this is invalid because it's negative. X is 12 centimeters from this solution here. So X is 12, and we've done that then. Part B, let's turn our attention to that now. Now we've got a triangle XYZ. XY is 32, so I'll try and draw it in as best I can. The angle XYZ is 19, that's why I've drawn this angle here quite shallow. I'll put that as 19 degrees. XYZ, let's try it like that. XY is 32. Oops. 32 then. It's not quite drawn the correct way, is it? And this is 15. So it should have been the other way around. So maybe if I put this as X and that Z, that might look pictorially a bit better, mightn't it? So let's do that as X, let's do that as Z. And then we've got XZ. The angle XYZ is 19 degrees. XY is 32. XZ is 15. There we go. Okay, good. And also now find the possible values of YXZ. So YXZ, we need to find this angle here, don't we? Okay. So we've got this side, we've got 3 of 4, haven't we? We can find the sine of this, and once we found this angle, we can find this angle. So let's do that then. So Z over 32 over sine of Z, 32 over sine of the angle at Z is equal to 15 over sine 19. So that tells us then that sine Z is going to equal, move the sine up to be with the 32, sine 19, move the 15 to be underneath, and then move the sine Z up to be on this side and read from right to left, and this is what we get. So shift sign then. Sine is going to be positive, so don't forget there's 2 possible solutions for sine, here and here. So we've got an acute angle. Let's do the acute angle. This is positive, so let's do shift sign. So we need to be in degrees mode, shift mode. Degrees is number 3. So inverse sine, shift sine, of 32 times sine 19, close that bracket, divided by 15, close the shift sign bracket, equals 43.99, so that's 44 degrees. So that tells us then Z equals 44 degrees. But the other solution we're going to get is, because that's 44 here, this will be 44. 180 minus 44 is 136 degrees. So those are the two possible solutions for sines for the Z value then. Okay, so that's Z. So in that case then, we can read off the, so the angle then, YXZ, angle YXZ equals, so 44 and 19 is 63. 63, so that would be 117 degrees, won't it? 180 minus 63. And we've got 19 and 36 is 155. We'd need 25 more, wouldn't we? So 25 degrees to get to the 180. Or 25 degrees. So the angle in question is 117 or 25 degrees.